Alkanes and halogenoalkanes. State what happens where the chain breaks. It's random, therefore you get a different mixture of products every time you crack a hydrocarbon. Crude oil is not useful. Now I'm going to go through that statement in a bit. Alkanes have general formula CnH2n. Every carbon in an alkane has 4 single bonds with other atoms. Alkanes are saturated. It's only single bonds. It can only form carbons can only form 4 bonds. It's impossible to have more than 4 bonds for a carbon. Cycloalkanes, a ring of carbon atoms with 2 hydrogens attached to each atom. A ring of carbon atoms with 2 hydrogens attached to each atom. CnH2n general formula, but it is saturated. Petroleum, a mixture of hydrocarbons made up of alkanes, fancy word for crude oil, petroleum, and sticky black stuff that we get out of the ground with oil wells, crude oil. Using a catalyst cuts costs, therefore reaction done at low pressure and low temperature. State key thing about doing fractional distillation lab, we need to use a safer crude oil substitute instead. Fractional distillation, how does it work? Crude oil vaporizes at 350 degrees Celsius. Vaporized crude oil goes into fractionating column, rises up through the trays. Largest hydrocarbons don't vaporize at all because the boiling point is too high, therefore they run to the bottom forming a gooey residue. As the crude oil vapor goes up the fractionating column gets cooler. Alkane molecules have different chain lengths, therefore different boiling points. Therefore each fraction condenses at a different temperature. Fractions are drawn off at different levels in the column. Hydrocarbons with lowest boiling point don't condense, they're drawn off as gases at the top of the column. Cracking involves breaking long chain alkanes into smaller hydrocarbons. Thermal cracking, high temperature, 1000 degrees Celsius and high pressure, 70 atmospheres of pressure. Produces lots of alkenes used to make heaps of valuable products, polymers, plastic. Example is polyethylene, which is made from ethene. Catalytic cracking uses zeolite catalyst, hydrated aluminosilicate. That's not really necessary, you just need to know it uses zeolite catalyst, right? High temperature, 400 degrees Celsius, 450 degrees Celsius, slight pressure, produces aromatic hydrocarbons and motor fuels. And yeah, using a catalyst cuts cost, therefore reaction done lower pressure and lower temperature. And that's it for this part. Yeah. So yeah, crude oil is not useful. Therefore, it is useful though if we use fractional distillation to vaporize it and then split it up, right? Okay, alkanes and halogenoalkanes, carrying on. Alkanes are great fuels, burning a small amount releases a large amount of energy. Burn in power stations, central heating systems, power to boost power car engines. However, burning alkanes produces lots of pollutants. CH4 gases plus 1.5 O2 gases to form CO gases plus 2 H2O gaseous. CH18 gases plus 10.5 O2 gases form 4 CO2 gases plus 4 CO gases plus 9 H2O liquid. And both of these is not an excess of oxygen. Therefore, it's incomplete combustion. We get carbon monoxide, and we can also get carbon dioxide when hydrocarbon undergoes incomplete combustion. Carbon monoxide gas can be removed from exhaust gases by catalytic converters on cars. Now, carbon monoxide gas is poisonous. Carbon monoxide molecules bind to the same sites in hemoglobin molecules in red blood cells as oxygen molecules. Bind to the same sites in red hemoglobin molecules in red blood cells as oxygen molecules. Therefore, oxygen can't be carried around the body. Therefore, it can be dangerous. Soot, SOOT, carbon particles, or soot, whatever you want to say, can be formed by incomplete combustion. CH4 plus O2 would form C plus 2H2O. Soot causes breathing problems. It builds up in engines, therefore they don't work properly. Carbon dioxide is a greenhouse gas. Greenhouse effect. Greenhouse gases in atmosphere are good at absorbing are good at absorbing infrared radiation, bracket heat, emit some of the energy they absorb back to the earth, therefore keeping it warm. Increasing the amount of carbon dioxide in the atmosphere making the earth warmer. This whole process is called global warming. Unburned hydrocarbons and oxides of nitrogen can cause smog. Engines don't burn all the fuel molecules, some come out as unburned hydrocarbons. Oxides of nitrogen produced when high pressure and high temperature in a car engine cause nitrogen and oxygen from air to react together. Hydrocarbons/nitrogen oxides react in presence of sunlight, forming ground level ozone component of smog. Catalytic converters in cars remove unburnt hydrocarbons and oxides of nitrogen from exhaust. Fossil fuels contain sulfur. When burnt, sulfur reacts to form sulfur dioxide gas. Ground level ozone irritates people's eyes, aggravates respiratory problems, some extreme cases causing lung damage. Sulfur dioxide gas, if it gets into the atmosphere, dissolves in moisture, sulfur dioxide gas gets into atmosphere, dissolves in moisture, converted to sulfuric acid, causing acid rain. And same happens when nitrogen oxide escapes the atmosphere. Nitric acid is produced, HNO3. Acid rain destroys nitric acid produced. Acid rain destroys trees and vegetation, corroding buildings and statues, plus killing fish in lakes. Sulfur dioxide can be removed, though, fortunately, from power stations, flue gases before they get into the atmosphere. Powdered calcium carbonate or calcium oxide mixed with water to make an alkaline slurry. When flue gas is mixed with alkaline slurry, the acidic sulfur dioxide gas reacts with calcium compounds, forming calcium sulfite, a harmless salt. So powdered calcium carbonate or calcium oxide mixed with water to make an alkaline slurry. When flue gas is mixed with alkaline slurry, acidic sulfur dioxide reacts with calcium compounds to form calcium sulfite, which is a harmless salt. Free radical, a particle with an unpaired electron. Free radicals form when covalent bond splits equally, giving one electron to each atom. Unpaired electron, therefore very active. Free radical, a particle with an unpaired electron. Halogens react with alkanes, forming halogenoalkanes in photochemical reactions. Reaction started by ultraviolet light. Free radical substitution, a hydrogen atom substituted by chlorine/bromine, or replaced, you could say, by chlorine/bromine. Chlorofluorocarbons, halogenoalkane molecules where all the hydrogen atoms have been replaced by chlorine, fluorine, /fluorine atoms. Ozone in upper atmosphere acts as a chemical sunscreen, absorbs the ultraviolet radiation from sun. Ultraviolet radiation causes sunburn/skin cancer. State how ozones form naturally. When oxygen is broken down into two free radicals by UV radiation, free radicals attack other oxygen molecules, forming O3, ozone. State three key characteristics of chlorofluorocarbon, CFCs: pretty unreactive, non-flammable, non-toxic. Pretty unreactive, non-flammable, non-toxic. Three key characteristics of CFCs. Say two uses of CFCs: cooling gas in fridges, as solvents. It's just that, say three uses of CFCs: cooling gas in fridges, as solvents, propellants in aerosols. Chlorofluorocarbons causing damage to ozone layer, and therefore the advantages of chlorofluorocarbons couldn't outweigh the environmental problems it was causing. Therefore, it was banned, because it's causing damage to the ozone layer. Chemists develop safe alternatives to chlorofluorocarbons containing no chlorine, so the CCl bond can't break. HFCs, hydrocarbons. HFCs are hydrofluorocarbons, and then hydrocarbons. Halogenoalkane, alkane with at least one halogen atom in place of a hydrogen atom. Alkane with at least one halogen atom in place of a hydrogen atom. Say why carbon halogen bonds are polar. Halogens are much more electronegative than carbon, therefore the delta positive charge on carbon therefore is prone to attack from nucleophiles, and nucleophiles are electron pair donor. Say three nucleophiles reacting with halogenoalkanes, OH- Cn- NH3. Nucleophilic substitution reaction: nucleophile reacts with a polar molecule by kicking out its functional group and taking its place. Nucleophile reacts with a polar molecule by kicking out its functional group and taking its place. CF, CCl, CBr, CI. As you go down, faster substitution. As the bond enthalpy decreases, aka the bonds are getting weaker. Carbon halogen bond strength decides the reactivity for a reaction to occur. Carbon halogen bond needs to break. Now we might be wondering, Iman, where's all the mechanisms and all of that? That's just going to be in the mechanism playlist. I'll probably go through all the mechanisms in the upcoming weeks, going through mechanisms. But yeah, this is just all the key information for this topic. Mechanisms in the separate playlist.